This is a previous year board question from haloalkanes and haloarenes, a give reason question. Haloalkanes, though polar, are insoluble in water. Haloalkanes can be represented as Rx. So between two molecules of haloalkanes, there is a dipole-dipole interaction. Dipole-dipole forces are there between two molecules of haloalkanes. And in the case of water molecules, H2O and H2O, you have hydrogen bonding. Now for an haloalkane, this is hydrogen bonding. To be soluble in water, these two dipole interaction and hydrogen bonding have to be broken. So in order to break those bonds or those interaction and hydrogen bonding, a lot of energy is required. So that energy should come from, because these haloalkane molecules have to be separate in order to bond with water molecules, or in order to form dipole-dipole intermolecular forces between haloalkanes and water have to be formed. But when that intermolecular bonding or intermolecular forces are formed between haloalkane and water molecules, the energy is very less. That energy will not compensate for the high amount of energy required for the breaking of hydrogen bonding or the dipole-dipole force between haloalkanes and water molecules. So this much energy is not provided by the energy released during the formation of dipole-dipole intermolecular forces between haloalkane and water molecules. That is, say between water molecules H2O and H2O. If a haloalkane is to dissolve here, this bond has to be broken and this has to come as Rx. So that requires a lot of energy. When this, if it is dissolving in this, if it is coming in between the water molecules and dissolving, energy is released. But that energy released is very less. That is why haloalkanes are not soluble in water. They are polar because Rx bond, because of the electronegativity difference between carbon and halogen, they are polar. But the energy released by the formation of dipole-dipole intermolecular forces between haloalkane and water molecules is not enough to compensate for the large amount of energy required to overcome the hydrogen bonds in water molecules and the dipole-dipole interactions between the haloalkane molecules.